Hello class, this is Mr. Parsons here. Just want to take a few minutes to talk to you about linear versus nonlinear functions. Alright, so a function is linear when you have a constant rate of change. Alright, that's going to help you distinguish that. And we're going to be able to look at that in three different ways. Alright, the first way is an equation. So if you have the format of y equals mx plus b, we'll talk about this more intensely in another lesson. But if it's in this format, then it's going to let you know it's a linear function. If you look at a table, if you have a constant rate of change, all right, so x is changed by a constant value and the y's value by change. So an example of that would be like 10x. So you get paid like $10 an hour. So for every hour you work, you get paid at a rate of $10. That's like a constant rate of change. Another way is looking at a graph, linear graph. If the graph forms a straight line, no matter what direction the graph is in, if it's a straight line, it's going to indicate a linear function. So let's take a look at these here. So we're going to look at these examples and indicate if it's a linear function or not. So we're going to substitute, this is our equation. We're going to substitute x for these numbers. That's going to give us our output, which is y. So we're going to do 1/2 times -4. That's going to give us -2. 1/2 times -2. That's going to give us -1. 1/2 times 0, because we substitute x for 0, it's going to give us 0. 1/2 times 2, that's going to give us +1. And 1/2 times 4, it's going to give us 2. So this is our table. And if we look at our order pairs, -4, -2, -2, -1, 0, 0, 2, 1, 4, and 2, if we plot these on our coordinate plane, it will look like this. All right. So it's a straight line. We have a constant rate of change, which is 1/2 times your input. And this is in a format of y equals mx plus b. Now, I know you don't have your plus b here, but you still have a constant rate of change. So it's still in that format. So because of that, this function is going to be linear. It's going to be a linear function. Now, if we look at number 2, we're going to do the same thing. We're going to substitute x for our values here. All right, so -2 to the second power is going to be 4. 4 plus 1 is 5. All right, -1 to the second power is 1. 1 plus 1 is 2. 0 to the second power is 0. 0 plus 1 is 1. 1 to the second power is 1. 1 plus 1 is 2. 2 to the second power is 4. And 4 plus 1 is 5. So these are order pairs, -2, 5, -1, 2, 0, 1, 1 and 2, and 2 and 5. And if you was to plot these on our coordinate plane, it will look something like this. Now, if you notice, this is not a straight line. This is not a straight line. So because it's not a straight line and it's not a constant rate of change, this function is not going to be linear. It's not in the form of y equals mx plus b. And we could tell because you have an exponent. All right, that's not in that same format. All right, it's not a constant rate of change, and the graph is not a straight line. Let's take a look at these. We're trying to explain if these are linear or not. So let's take a look. So if we substitute each value for x, all right, our table will look like this, because -2 to the third power is -8, -1 to the third power is -1, 0 to the third power is 0, 1 to the third power is 1, and 2 to the third power is 8. So this is our table, and if I was to plot these on a coordinate plane, it will look something like this. Now, if you look, this is not a straight line. So because it's not a straight line, it's not a constant rate of change. It's not in that format of y equals mx plus b, because you got raised to the third power. This is not linear. It's not a linear function. All right. Look at number 4. We're going to do the same thing. Substitute x for these values to give us our output. And when we do that, it'll give us this table here. So we have these ordered pairs. All right. So we have these ordered pairs, and we plot them on our coordinate plane here. It'll look something like this. Now, if you look at this, hey, this is a straight line. So because this is a straight line, you have a constant rate of change. All right, it's in the format of y equals mx plus b. All right, this is going to be a linear function. All right, now let's look at number 5. All right, 12 divided by x. So we substitute x for each number. when we do that, we'll get this. These are our ordered pairs here with our table. And if we was to plot this, it'll look something like that. All right, now if you look at the graph, it's not a straight line. It actually curves. All right, this is not a constant rate of change. All right, and it's not in the format of y equals mx plus b. All right, so because of that, then this is not a linear function. All right, so let's take a look at these to help us. Todd noticed that both proportional and linear relationships form a straight line. So when you're talking about that, you're thinking about like unit rates, constant proportionality, and whatnot. You're trying to make that connection. And it's saying that all linear relationships must be proportional. Well, now all proportional relationships must be linear because it has a constant rate of change. But not all linear relationships are proportional. And the reason being because a proportional relationship has to pass through the origin. If you remember when you talk about constant proportionality, and if it's a proportion, it has to pass through the origin. Well, linear functions and relationships doesn't necessarily have to pass through the origin as long as it's a straight line. All right? So that's why all proportional relationships doesn't necessarily have to be linear. But linear, all proportional relationships must be linear, but linear proportions relationships doesn't necessarily have to be proportional. Now, if you look at number 7, we can look and see if this is linear or non-linear. Think about it. Y equals mx plus b. So as long as it's in that format, and it doesn't have to be plus b, but it could be a deviation of that particular equation. So anytime you see like raised to a power, or if you divide by that particular input, then you're not going to have that same constant rate of change. So if I look at A, y equals 4x to the second power. See, x to the second power, that throws that off. That is not going to be the same format as y equals mx plus b. So you're not going to have the same rate of change. So because of that, it's going to be nonlinear. But if you look at b, y equals negative x minus 1. Now, negative x minus 1, all right, it's still going to have that same rate of change. It's not raised to a power, your x isn't, and it's not being divided by another number, anything like that. So because of that, you're going to have the same rate of change, and therefore b is going to be linear. Now c, 10 divided by x, c, you're not going to have the same rate of change. All right? And because of that, this is not going to be linear as well. All right? And then if I look at number 8, it says several students made a relationship about x and y. All right? Circle the student who made a correct statement. So let's take a look at this. If we look at this here, all right? 2, 0, 0, 2, negative 4, 4, negative 16, 6, negative 36, 8, and negative 64. These are not going to give you the same rate of change. All right? If you're trying to look at a particular pattern, and when you graph it on a coordinate plane, it's not going to give you a straight line. All right? So this is going to be a nonlinear relationship. All right? So we're trying to see which one of these students made the right statement. Tabitha said the relationship is nonlinear because as x increases, y decreases. Well, as x increases, y decreases, that is correct. But you more or less want to look at the relationship like the constant rate of change, not necessarily increasing and decreasing. That's not going to determine if it's linear or nonlinear. All right? This student states that the relationship is nonlinear because as x changes by a constant value, y do not change by a constant value. And that's what we're looking for. If your output changes as a result of x changing by a constant value. So that's correct. And then lastly, Luke says a graph for the relationship will not show a straight line. Well, in order for a function to be linear, it has to have a straight line. So if it's nonlinear, that means it does not have a straight line. So therefore, Luke has also made a correct statement. So these two students here made correct statements as far as why this table is nonlinear. So just to recap here, to make a function a linear function, it has to be in that format of y equals mx plus b. As a table, it has to have the same rate of change or the same unit rate or the same constant proportionality. All of those are interchangeable. And then thirdly, your graph has to be a straight line. And if it fulfills any or all of those requirements there, then you have a linear function. So hopefully this helps with our understanding of linear versus nonlinear functions.